Good morning, grade 12 STEM, and welcome again to our physics class. For today's lesson, we will continue our discussion about electricity. Okay, so before we proceed to our topic, let us first recall what was our last discussion. Okay, so I will give you a short or summarized, okay, discussion about what we have tackled last time. Okay, so I will share the screen of my friend. See some of these. Okay, I have a whiteboard, so I will draw. Okay, about what we have tackled last time. So last time we did. Okay, I will just find the marker. We did what we call the static electricity, right? Now, to understand this one, we need to review first the particles that we have, okay, in the whole world, the smallest particles. Okay, so we have here what we call an atom, right? The smallest particle. So an atom has, I will draw an atom here. So this will be an atom. Okay, then I will put something inside and on the outside. Okay, so this is what we call atom, and inside of this one, or the parts of this one, are this. So inside, okay, of course, if we have a particle that's inside, is what we call the nucleus. Okay, so this nucleus consists of two particles. We have the positive particle and the neutral or zero particle. So what do we call those? The positive is what we call the proton. Okay, that is the proton. And for the neutral one, okay, so this is what we call the neutron. Those are the two particles that are stick together at the center of the atom, which is what we call the nucleus. Okay, and then this part, this black one here, that I colored black, these are what we call the negative particles or the electrons. Now, how is it related to our topic last time? Static electricity. Okay, so as you can see here, you can count the number of electrons. So we have how many? We have one, two, three, four. Okay, and we can uh, compare that one to the number of the proton. So how many protons do we have? One, two, three, four. Okay, if we have a balanced number of electrons and protons, that means this is stable. Okay, when we say stable, it's nothing happens. Okay, so this one is normal. Okay, so it will become neutral. If this one is normal, so it will become neutral. Okay, but if we have an extra neutron here, or electron, I should say, if we have an extra electron here, and this one now is electrons are greater than protons. Okay, this is not neutral now. This is now imbalance. Okay, so we can call this as a negative charge. Okay, again, if the electrons are greater than the number of protons, it will become negative charge. Okay, and if we have here greater than, or number of protons are greater than the number of electrons. Okay, so this will become positive charge. Positive. Okay, so we have here the positive charge. So these are the three or basic things that we must know first before we proceed to the static electricity. Or how can we understand static electricity? Okay, if we have neutral, that means the number of protons and number of electrons are equal. If the number of electrons are greater than the number of protons, we call this negative charge. If the number of electrons is less than the number of protons, then we have a positive charge. Now, I will get the two presentations here, okay, about protons and electrons, and I will relate that one into our or into the static electricity. Okay, so I will choose these two. One, two. Why? It's because these two are talking about imbalance. Imbalance. And this word is the main summarization of static electricity. So when we say static electricity, this is about imbalance of charges. Okay, so if there is an imbalance of charges, so it will create a static electricity. Now, to make this um, more deeper, I will add more here. Ayan, magdadagdag ako ng isa. So we have this one and this one. So let us still continue about static. We already know the basic knowledge or the basic, the basic parts of it. So to deeply understand this one, for example, I have here person. Okay, so a person's body has, sometimes there is an imbalance. Okay, how does it happen? For example, you rubbed, okay, you rubbed your hands, rub your hands, okay? If you rub your hands, that means you are releasing, releasing, release. That means you are just like putting out of electrons, okay? So those electrons will move out, okay? And then they will go to a certain thing. Right? If electrons moved out, they need to find something that make them balance. Okay, so maghahanap sila ng protons. Okay? So for example, they found a knife. This is a knife. Okay, for example, this is a knife, and this knife absorbed all the electrons coming from your body that you rubbed. Okay, so this one now has a lot of negative charges, so it will become negatively charged. Okay, this one is now negatively charged, and since your body releasing electrons or negatives, your body now will become positively charged. Okay, and then if you want or if you accidentally touch, okay, if you accidentally touch this knife, then it will create a sudden spark, or what we call the zap. You know what zap is? Zap, that means like if you're holding something and it's, have you experienced that one? Right? Just like every time, for example, your classmates are playing with his feet, right? Uh, his shoe was parang mirror niya dun sa floor, and then suddenly touch you and it will create a zap. That is a zap. Right? Or a sudden spark. So parang makuryente ka ganyan. Right? So that is the effect of the static electricity. It's because your electrons needs to find something para maging balance ulit siya. Since this thing is already balanced and then doon pa rin siya pumunta, it's because it is still has protons. So doon siya pumunta, so it will become negatively charged. And then since it came or it parang lumabas siya sa'yo, it releases. Okay? Galing siya sa'yo, and then you will become positively charged. And if you will handle this one, or if you touch this one, then it will create a zap. And that is what we call static electricity. That is the effect, right, of imbalance charges. That is static electricity. Now, let's continue our discussion. Since we all know about static electricity, let us now know how to solve certain things. Okay? So, paano ba solve ng certain things in terms of electricity? And then we will um, relate that one into our last topic, which is the static electricity. Okay, yeah. So I will now share my screen, share my own screen. This will be our topic for today. This is about the Coulombs Law. Coulombs. Okay, it's something like it's new to us. It's Coulombs Law. Have you ever encountered this word sa inyong mga grade 10, grade 11 classes in the sciences? Okay, so maybe yes, maybe no sa mga ibang students. Okay? But for me, this is just, just a reviews because I already encountered this one when I was in college. Okay, so let's continue our discussion about the Coulomb's law. Of course, if we will say law, drawing ako ha. Ayan. If we will say law, okay, this is actually developed or this is actually observed or solved by the scientists. So when we say solve, it has a formula. So yung Coulomb's law na yan, it includes a formula. Okay? So we will tackle this one. Now, let's continue. Eraser ko. Erase. Okay. Now, how do electrical charges interact with one another? We have a main word here, which is interact. Mhm. When we say interact, that means how they are uh, communicating, something like that, and synonyms. Okay, so how they are related to each other. So, kumbaga, we have two charges, right? The negatively charged and the positively charged. So, if we have negative and positive, how they can interact to each other? Are they going to combine or are they going to separate? Okay, those are what we are going to tackle now, and then how to solve those problems. Okay, using the Coulomb's law. Okay, so these are our objectives. Predict the direction of the net force in a charge in a system of charges. State the Coulomb's law and calculate net electric force in one-dimensional and two-dimensional problems. Okay, but now here we will just concentrate on one-dimensional. Okay. And if we still have time, then we will proceed to do two-dimensional problems. And of course, solve problems involving electrostatic forces in the context of systems of point charges. Okay, so it sounds like tricky, but we can do it. Okay, let us do this one first. Suppose you have a positively charged sphere fixed on a wall. Okay, so this will be our positively charged sphere or something. Okay, and what happens if you place another positively charged sphere? We already discussed this one last time, right? So if we have the same charges, they will attract or repel. Of course, they will repel. Like charges, repel. Maghihiwalay sila. Hindi sila pwedeng magka-dikit. Okay? So, just like you in your crush. I'm just kidding. You, okay? Uh, they will repel. The same, repel. Okay? Next one. What happens if you place another negatively charged? So if we have like, they will repel. If we have unlike signs or unlike charges, of course they will attract. Unlike charges, attract. Again, the same, repel, unlike, attract. Okay? Easy to memorize. And charges exert force to one another. What is that force? What is that exert? Anong exert na yan? What are the synonyms of exert? When we say exert, it's like nilalabas. Tama? So meron silang parang binubuhos na force, okay, to one another. Maybe they are attracting to each other, they are pulling each other, or they are pushing each other. Something like that. Okay, that's what we call the exert force. Now we will concentrate on this one, the force. So how can we find that force? Okay, so this one is actually includes in our lesson, which is the Coulombs Law. Okay, so we can solve the force using the Coulombs Law. What are the factors that affect the forces between two charges? What are the factors that affect the forces between two charges? So what are those factors? Maybe it's about the environment, maybe it's about the distance or something. Okay, so we can learn those every thing here. Suppose two charges exert force to one another. Okay, so we have positive and negative. How do we quantify the force? How do we quantify the force? When we say quantify, it's about solving. How do we solve the force here if they will attract? They will attract, right? It's because they are unlike signs, so they are attracting each other. So how do we quantify the force, or how do we solve for the force for this? What happens to the force when we increase their distance? It's still unlike, but the distance are getting bigger or getting larger or longer. Okay? So still we can find the force. So either malapit yung dalawang particles or malapit yung dalawang bagay, okay, with positive and negative charges, we can also solve for the force. Gaano kalakas yung force na yan? Mas malakas ba yung force kapag malapit sila or yung malayo sila? Okay, so we can understand that one. This one, decrease their distance or we are just like near to each other. So is it greater force or lesser force? So it will include the solving for what we call the Coulombs Law. This is a short, actually, a short description of the Coulombs Law. So Coulomb's law is the magnitude of the electric force between 2 point charges that is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So when we say directly proportional, we already encountered this one and when you are in grade 9. So what will be the operation? When we say directly proportional, this is about multiplication. Okay? Inversely proportional, that means division. So we have the magnitude of the electric force between 2 point charges. So we have 2 point charges. So we have two charges. It's either positive or negative, or the same positive or the same negative. So as simple as that. Directly proportional, so multiplied by to the product of the charges. So we have here a constant thing. We have a constant thing here. Constant multiplied by the two particles, okay, or two charges, and inversely proportional to the square of the distance between them. So this will be the distance. So in arranging those formula, we have this formula here. Okay, I will discuss the formula so you can understand more. I will stop sharing this one, then I will share the whiteboard. Okay, here. So we have the formula. Okay, hintay natin yung white. Ayan. So we have the formula here. F. Katulad na yung E. Okay na yung F. F equals K multiplied by Q1, Q2 over R squared. Let us discuss one by one. F is for the force itself. Okay? And this force is, when we say force, what will be the unit? This is a Newton. Okay? The force is about Newton. And then for the K, this is what we call the constant. Okay? And the value of the constant, of course, constant. We already know that one, right? In our physics one. The value of the constant is 9 multiplied by 10 raised to 9. Okay? Newton meter squared all over c squared. What is c? C here is the column or the coulomb. Okay? C here is the coulomb. Remember that one, huh? This one is the coulomb. And coulomb is the unit for the static electricity. Okay? So we have the coulomb. Another thing, we have the Q1 and Q2. Q simply means quantity. Quantity of the particles. Okay, so we have two particles. So those are what we call quantity, or as simple as the Coulomb itself. So these are the Coulomb. Okay, so the Coulomb. And then the last one we have the R, and R represent as the distance between the two particles or the Coulomb. Okay, so if you will encounter that this formula, you need to know first what are their identification or identity. Identification talaga. identity. Okay, so F is for the force, K is for the constant or this one. So we will use this one. So you need to memorize this. Okay, this is part of the formula. So you need to memorize this. 9 by 10 raised to 9, that is 9 billion Newton meter squared over C squared or the Coulomb squared. Okay, and here we have the quantity or the coulombs. Of course, their unit is C. Coulomb is big letter C. Okay, the Coulomb unit or the symbol for Coulomb is big letter C. Okay, and then for the R, it's the distance between the two particles. Distance. What is the unit for distance? We have meters. So we are only using meters. So this one for the Coulomb, we are using C. And for the constant, this will be the formula. And for the force, we have N. Okay? You need to memorize all of these first before you can solve one problem. Okay? So this will be the formula to find the force. Okay? Okay, I will give you 5 seconds to, have a screenshot for this one. 1, 2, 3, 4, 5. Okay, I will stop sharing for this one and then let us try to solve some problems. Okay, okay, so for this one, let's practice. 2-point charges, Q1 is equivalent to 5C and Q2 is negative 3C. Okay, the meaning of C again, this is the Coulomb, correct? This is the one that's the Coulomb. So we have the positive and the negative. Okay, are separated by a distance which is r is equivalent to 30,000 meter. And then find the magnitude of the electric force that Q1 exerts to Q2. Predict whether it will be attractive or repulsive. Okay, so we have two main questions. We need to find the force and is it attractive or repulsive? Okay, so let us first recall the formula. We have the formula, another color. Okay, the formula we have here is F. We have K, Q1, Q2 over R squared. Okay, so let us find the value or the given to each of those parts. So we need to find F, K, Q1, Q2, and R. So what are the given of those? Alright, F. Do we have a given F? Of course not. It's because we need to find that. So F is question mark. How about K? K is the constant. So we have 9 by 10 raised to 9 Newton meter squared over C squared. Remember that one? I told you to memorize it. And then the Q1, so we can just choose, I know, we have Q1 there, that is positive 5C. So I will put 5C, which is Coulomb, 5 Coulomb. And then we have the negative 3C for Q2. Now, I will just need to, make this very clear. The negative sign here, it's not included. Okay, so instead of negative 3, I will find its absolute value. So I will use 3C. Always. Negative or positive, there is no, just like hindi siya gaano affected doon sa ating formula. So, if we have a negative, we need to find its absolute value para maging positive. Okay? So we have the 3C, and then for the R, we have 30,000 meters. Okay? Since we have here a, what we call, how do you call this one? Scientific notation, correct? If we have here a scientific notation, so we can also change this, okay, later on. Now, let us solve since we already have those given. Okay, now we can solve for this one. So I will just put F is because F is the one which is missing. Equals. We have the K, which is 9, multiplied by 10 raised to 9, n meter squared over c squared multiplied by Q1, which is 5c, Q2 is 3c, divided them by 30,000 meters. Okay? That's for the 30,000 meters. And then let's solve for this one. This will be, yeah, since we can see here, oh no, this one is with this square. So don't forget the square, okay? So we have here 9 by 10 raised to 9 and m squared, okay, over c squared, and we have 5 times 3, we have 15c squared, all over 30,000 meter. Oh no, 30,000 squared. 30,000 squared will be, ilang zeros yun? We have 4, so it will become 8 zeros. That is 900 million. Oh, yes, no, no, no. Okay, so we have 9, 1, 2, 3, comma, 1, 2, 3, comma, 900 million. Okay, correct. No, yes, 900 million meters squared. Now, you can see here that we can simply erase those units. It's because we can divide them, right? So meter squared, so we can cancel. C squared, we can also cancel, okay? And then, so we only have here equals 9 by 10 raised to 9 is actually 9 billion. 1, 2, 3, 1, 2, 3, 1, 2, 3 Newton over, no, no, multiplied by 15, okay, over 900 million. Okay, now let's find the final answer here. I will put here. There's no space. Okay, so we have how many zeros up there? We have 9 and we have 8 here. Chum. Then we have 8. And then 90 divided by 9, we have 10. Right? So they cancel. So 10 times 15. So we have the final answer for force, which is 150 Newton. That is the answer for the first one. And then we need to find or predict if they're attractive or repulsive, since they are unlike sign are attract, right? So with this one is 150 Newton and they are attractive. So this will be the final answer. Okay? Okay, screenshot in 10 seconds. 1, 10. Okay, good. Now, next example. Okay, I'll stop sharing again. And then I will just share the screen of my friend. Okay, so I need to find this one. Can you see it? Let's see. I can see it. Okay, wait, wait.